Welcome to the acetylene room at Hurst Lighthouse, and this is where of course they made acetylene gas over the years to light the lights, not only the one outside but also the one on the castle wall. But before we start that, a little bit of history. The first lighthouse, as you see on this diagram here, was built in 1786. But that wasn't built here, it was actually built on top of the castle. If we look at the diagram here, we can see there's the drawing of the castle, but these parts here didn't exist at the time because they hadn't been built. So there is our lighthouse sitting there. And if you've been in the castle at all, then where the cafe is, that's roughly where the lighthouse sits, or was. Now, later on, they built another lighthouse in 1812. And the purpose of that, if you have two lights, and these two lights are in a line, then the ships can get the ship in line with the two lights, and then he knows he's on a correct bearing for the safe channel. So if we look at this diagram now, you can see the two lights. There is the deep water channel, and if we draw a line across there towards the needle, if the ship is seeing those two lights in line, then it's in a safe place, keeping well clear of the shingles bank. Now going back to the first diagram, as time progressed, then around the 1860s, it was necessary to build these fortifications here with all the cannons. It was probably the biggest one in the world, because it had some 32 cannons. Now, because we built that, then, if you like, you can see that the lighthouse is now in the way, so that had to be demolished. They also demolished the one built in 1812. And in their place, they built a new lighthouse, which you see is there, and is the one outside the building today, built in 1865. At the same time, they built a new lighthouse on the castle wall. That's known as a stone light, and when you look at it, you'll see it's built of stone and has glass windows around the top. Now that one is quite unique because the keepers couldn't get into that lighthouse from inside the castle, and you had to go outside, and when you walk back after seeing this by the ferry and look at the castle, and you'll see the doorway, which has now been bricked up, where the keepers used to go in. Of course, you couldn't have lighthouse keepers in a military establishment. So, back there we've got two lights and got our bearing line once again. Now as time progressed and we got to the turn of the century, the shingles bank and the channel had moved, so we needed to alter this bearing line. And so you can't pick up a lighthouse and move it, so the only way is to build another one. And so the second light, which you see today is painted grey, but at the time was painted red when it was operational, that is now in that position to move the bearing line. And so there we are. So there's the layout of the lighthouses. Now in the early days, of course, the lights were not electric or anything like that. They were actually oil lights. And they were something like this. So what you had was whale oil in the box here, came along the channel to the end, and a little flame at the end. But that flame, quite a cold flame, it was yellow and it was quite smoky. But you'll see we had a nice reflector here, so that helped the light. And because it was smoky, we had a chimney. Now as time progressed, we're all looking for a better light, so we look at this one. This one, made by a guy called Argan, a Frenchman. The significant point about that is the oil is down the bottom, but the real important part is that the wick is actually a cylindrical wick, and it sits in the middle here. So air now can come around the side of the flame. It can also go up the middle and into the bottom of the flame there. A glass chimney on the top would cause it to draw quite well. So there we are. So those are the lights were right up to the turn of the century. Around the turn of the century, we were looking for better sources of light, and gas light was ideal. And here, this is where acetylene gas has been invented. Acetylene comes from calcium carbide, and where you put water on the calcium carbide, and that makes acetylene gas. Now where does the calcium carbide come from? It comes from lime, which you dig out of the ground. You put the lime into a furnace with some coke, and that's an electric furnace, and you heat it to at least 2000 degrees C. When you've heated that temperature, the calcium carbide will run out as a liquid. That solidifies when it cools, it can be broken up, and now you've got your calcium carbide ready to use in your lights. Crunch it up a bit into small ice particles for easy use. So, around the 1920s, of course, vehicles had lights something like this. This is an early gas light on a bicycle, where the top part here would be water and the bottom part is calcium carbide. Water drips onto the calcium carbide and that produces your gas. The gas is fed through the little burner in the lamp here with a reflector, and you light that with a match, and therefore you've got a nice light. That sort of light is ideal for your bicycles and cars and things, but for a lighthouse we need lots more gas. And therefore, the unit we have here in the acetylene room is what was built to drive that. So let's go upstairs now and have a look and see how it works. And here we are at the top. And what have we got here? This container is like the old gasometer you used to see yesteryears at gasworks. What we've got is a big drum and another cylinder which fits into it. The piece on top, this piece here, like a dome, and it's open at the bottom. Now what happens is, the calcium carbide is put into this container here. It's only up here, so we can show you what it looks like. Calcium carbide in the form of crystals is put into there, and it will come out of the hole at the bottom. This lot is actually fitted inside this, and then the lid put on and sealed tight. Now, to start the whole thing off, there's a lever downstairs, which I'll show you later, opens the valve here, and allows some calcium carbide to fall into the water. Once it falls into the water, what have we got? Acetylene gas produced immediately. That, because it's all sealed, produces a pressure, and the whole of this unit will then rise up under the pressure. As the gas is used, it'll sink back down again. Now, as it sinks down, it once again hits the plunger, opens the valve once again, more acetylene in the water, more gas, and off it goes again. So this will now continue to go up and down for as long as you've got calcium in there. This will last for something like 2 or 3 days. So we're now actually in the era of starting to be lighthouse becoming automatic or even semi-automatic. This is deemed to be semi-automatic because now the keeper doesn't need to live here anymore. And in fact, where we're standing today is where the keeper's cottages used to be. And because now the keeper lives in Milford, and all you have to do is look across and see if the light is on and all is well. Every 2 or 3 days he comes along to tend and refill the thing. Now, gas is now produced in there. If you like to come further along, and if you like to look down there, you can see the pipe joining the two across right down the bottom. Join, that's it, lovely, down there, and that runs along and comes along to this middle unit. So although we've got 4 units here which actually produce the gas, they're not always in service at the same time. But this unit in the middle really is a gasometer. And what that does, the gas comes in, and once again it's filled with water, and then the middle part will rise up. As it rises up, you see those weights, it pinches on those weights, and then it operates the levers down the bottom. Okay, see the levers down the bottom, and they control the amount of gas coming in. And by that, it actually regulates the pressure, so we've now got a constant pressure coming out. Because the pressure in each of these 4 units we have here could be any pressure depending on their state at a particular time. The gas is now ready to be used. So it comes out of the pipe here, this one down here, runs underneath the bed, gallery, and then it comes up to this end. If we like to come further along now, and if you look down through the grating, you'll see 3 containers. Those containers are filters, and they had something like probably charcoal in them to filter out any impurities. The gas is really now ready to be used, and now it runs out around the pipes. And if I can run them around the wall, and there, all the way along, go around the other side, you can see it just goes over the top of the door, and then down into the ground by the side of the door there. And that gas then went down through there, and then up into the lighthouse to light the lights. Now I mentioned there is another lighthouse on the wall, the steel one, and the gas for that went down a pipe in that corner over there. And so you had the 2 feeds of gas. Right, now I did say that we need water in here for the thing to operate. But we really need fresh water. So, where do you think where fresh water might come out here? Because remembering out here on this bit, we've got no services at all. There is no gas, water, electricity, sewage, or nothing. So what have you got? Any ideas?
Possibly rainfall.
Rain, yeah, well done. Rain. And how do we get the rain? Well, if you look up at the roof is actually like a big bath on the top with high walls to collect the water, and you can see the big black pipe there, and the water collects on the roof, comes down that pipe, and runs into that big green tank. And that is connected to this tank, so you've got 2 big tanks of water. And that is the water, pure water, rainwater, which is used to operate here. Piping underneath feeds it to where we want it. Now, if you come along here a little bit further, that is fine when we have our usual rainy seasons we have. However, occasionally we do have a dry summer, and we might run out of water, and there's a pump on the wall, and that pump is operated, and that actually goes down to a well in the ground. Unfortunately, that well is so close to the sea that you can guess what, all we've got is salt water. So we don't use that very often, only when we need to, because of the corrosive effect. Now, going back to, we said the calcium might last for about 3 days, it then needs to be replenished. To replenish it, using the gantry, you see up top here, and using the hoist over there. Okay, the hoist, and that comes along, and we can use that, coming back, to lift these very heavy lids. You can see they're very heavy, and you're hitching them on there, you can open it. Having got it open, the grating up there doesn't come in, and then you use these rather large jugs here, because the calcium comes in a sealed container, and you put some in there, and you pick up that rather large jug, and pour it in, like pouring milk into your tea. Once you've done that, clamp the lid down, bingo, we're off to set again. And there we are. So now we'll go downstairs. To start the whole operation off, we have these levers down here. This one here, which we can turn, and that works a crank underneath, which pushes a lever up inside, and that then operates the valve to let the calcium come into the water. If he wants to stop the operation, he turns it to the shut position. You can see shut on there, and then turns it to that position, and that will run, so that when the system comes back down, then it won't go up again. Now, after a period of time, probably several months, in here we end up with a lime slurry, which is not ideal. We need to get shot of that. And so this rather large tap is done using a big lever like this. You see if you crank the lever, you pull that lever, and that then discharges all the lime or solution into this trough. That then runs right down through the building and out to the other side, and as outside there was a bund where it was collected. And then when that is solidified, the keeper would then shovel it out and chuck it on the shore and be lost. There was one other use for it, And that's where, because we had the army up here, and you know what, they always like their squaddies to paint things white. So what do? They send the squaddies down here, get a bucket of lime wash, take it back in the castle and paint it on the wall. Now, as we walk down to the far end of the room, you'll see this glass cabinet here. I wondered if anybody here can suggest what it's for.
Well, it seems to be a cabinet of some kind with some vent holes, and it looks like a Bunsen burner flame inside there.
Yes, that's right. It's actually two lights. One is the one at the front is actually a light, and you'll see that the burner is to 45 degrees, so the gas comes out, swirls with the local air, and forms and produces a nice white light. So that's useful when they're here in the dark. But the other real reason for this is the Bunsen burner at the back. That produces a hot flame, and what it does, it actually heats the whole of this cabinet and the glass as well. And what actually happens is air from outside flows around the sides of this cabinet and comes out here at the top. And the whole purpose of that is because when it gets frosty, we don't want the thing to freeze up. So it's not central heating, but it is sufficient heating to stop the system from freezing up. Okay, now the gas pressure comes on. We have to monitor how much gas pressure we got, and here we have the pressure gauge. A very simple thing where you have a U-tube of glass filled with water, and when the pressure's in, it pushes it down one side and up the other. And so a typical pressure is probably about 6 or 7 inches of water gauge, and that is typical, the same as gas pressure was yesteryear in the old town gas. Now in this cabinet we have got the mantles and things from the low light, which used to be on the wall of the castle. A similar device like this, which used to be in the lighthouse at the top, is now in the Treasury House exhibition room, also within the castle. Most lighthouses have a fixed light and then lenses which literally go around the outside, giving you a flashing light. Here the ranges are very short. The Isle of Wight's only 3/4 of a mile away. Very, very close. So that really wouldn't work very well. So they have to have a flashing light. And what we have here is a device which actually is a flashing gas light. And what happens? Gas comes into this red unit at the bottom, either one, there are 2 of them, only use one at a time. Comes into there, and inside that unit is a series of chambers, valves and diaphragms which actually produce a pulsating gas supply. So the gas which comes out of that big pipe there, around the top, actually gas comes on and off, on and off. How does it switch on each time? Because if you look carefully at the top, you'll see another little thin pipe right at the top, and that is actually the pipe for the pilot light. So there's a little tiny flame burning all the time. When the gas comes on, of course the gas will light, and when the gas goes out, it obviously just goes out. And that produces a light. The lens you see down the bottom wouldn't be down there. It would be mounted up at this sort of level so that the light is actually focused in the direction we want to go. Now, what happens when the mantle fails? The mantle, of course, it's all made of cotton, and that then is very fragile. What happens is, if it gets damaged, the gas flame can come outside of the mantle, because the property of the gauze keeps it inside. When it comes out, we need to change it. Now that could mean the keeper coming out every 5 minutes to do it. No, we haven't got time to do that. It needs to do it automatically, and that's what this device does. And you can see the arm up there with the mantle on it. And what actually happens, just below it, there's a little peg of wood. And when the flame escapes from the mantle, it burns a piece of wood. That allows the mantle to move up a little bit further, causing the clockwork mechanism in the bottom of that green part there to rotate and push the next mantle up into position. And bingo, we're back lighted again. And there you are, all done, very simply, all mechanical. No electronics, no internet. Okay? Right, so this place has been in existence now for quite some time. It came into service in 1922 and stayed operating in its present form until 1965. In 1965 it still used gas lights, But then they brought gas in pressurised cylinders, and this was no longer used. In 1998, that's when the lighthouse was automated, like all lighthouses. No lighthouse keepers anymore. They're monitored electronically and centrally in England and Wales from Harwich, that's Trinity House. There's a similar organisation in Scotland, which is run by the Northern Lighthouse Board, and a similar organisation in Ireland as well, and in other parts of the world similarly. So now, the light now works totally electrically. It doesn't need the two lights we talked about. And so now the light is actually worked purely by electricity. And the little shed outside is where the generators are and all the batteries in that room over there. The middle door containing the batteries. So there's no generator running now because the generator only comes on when the batteries get down and needs recharging. And as I say, one of the things we'd love to do, of course, is take you up the lighthouse. We can't because up the top we've got if you look right at the top there, the top window, you can see a black box, and that is part of the projector unit sticking out, and that unfortunately blocks the stairs. So the last part is a vertical ladder, and we all know what Mr. Health and Safety has to say about letting you people go up there. So there we are. So unfortunately, we can't do that. Now, this today has been presented by the Association of Lighthouse Keepers. I happen to be the secretary of that association, and we'd like you now to perhaps take away one of our leaflets, because this association formed in 1988 by ex-keepers and is there for everybody's interest. I was not a lighthouse keeper, but I've been very interested in it, and now we've got some 750 main members, mostly in England and Wales, also worldwide as well. And so you can be a member as well, if you've got interest, and so if I'd like you to take a leaflet. Thank you very much.
Thank you.